Hello everyone, let me introduce you guys to the project rBitcoin, which is essentially building a Bitcoin-like blockchain from scratch using Rust. And I'm assuming that you already have Cargo and Rust installed on your device and have a basic understanding of Bitcoin. And just to know that this video is just for the purpose of demo and introduction. So if you I want to actually look at how the verification, networking, and the hashing works under the hood, you should reference the code on the GitHub repo that I will attach a link to below. And let's get started. So I'm gonna open up the blockchain network on one terminal here named under Alice. I'm gonna open it and then I'm gonna join that network in this other terminal here with a node named Bob through this ticket number. And there we go. And we can also see in the logs that the node named Bob is pulling in all the state information about the blockchain from Alice, since Alice was a node that was in the network before Bob was. And let's run the command wallet just to look at the wallet on each node. So we can see that the node running wallet Alice has a balance of 50 coins where Bob has none. So we're going to initiate a transaction from Alice to Bob, transact Bob's address. Let's call it 15. We're just going to say 15 coins. Okay. And we can see that transaction object being created using the unspent transaction output models from Bitcoin. And we can also see how Bob's node has received that transaction from Alice's node broadcasting the transaction across the network. And if we run the command mempool to check the memory pool, we can see that that transaction is in fact stored in the memory pool in each node waiting to be picked up and mined. So we're just gonna mine that transaction with Bob's node, and that's been done already. So we can see that the Coinbase reward of 50 coin is going to Bob's wallet address for mining that block, and the block difficulty right now is set to having two zeros in front of the block hash, and that was the reason why it was so fast. And we can also see that the block has been broadcasted across the network and has been validated and received by Alice. So if we run the chain command to inspect the blockchain right now, we can see that the blockchain across two nodes are very identical. And if we look at the hash, previous hash, the hash of the Genesis block is 1E1F20, 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 and 1E1F20. And the hash of the block matches as well as the Merkle tree root, which is derived from hashing all the transaction data in a tree-like structure. Okay, and so there's that. And if we run the wallet command to check the wallet balance of each node, we can see that now Bob has a balance of 65, composed of 50 from mining a block and 15 from Alice. And Alice now only has 35 because Alice sent 15 coins to Bob. And let's examine the classic double spending problem that Satoshi Nakamoto was trying to solve in his original Bitcoin white paper. So from Alice's node, we're going to initiate a transaction of 35 coins to Bob. And that transaction object has been created and broadcasted and stored in the memory pool, and we can check that. And that is in fact there. And if we try to create another transaction referencing that same unspent transaction output, this should not go through. Yes, and we get an error in the log because that 35 coins has already been committed in another transaction in the mempool, meaning that the unspent transaction output has been referenced and it can only be referenced once. And we can go ahead and mine the transaction and look at the chain again. And if we look at the wallet balance, it should be finalized, and that is correct. So this is our very, very simplified product of a Bitcoin-like blockchain, and I hope you guys enjoyed it.